Network-attached storage.
Network-attached storage is file-level computer data storage connected to a computer network providing data access to a heterogeneous group of clients. NAS not only operates as a file server, but is specialized for this task either by its hardware, software, or configuration of those elements. NAS is often manufactured as a computer appliance, a specialized computer built from the ground up for storing and serving files, rather than simply a general-purpose computer being used for the role. As of 2010, NAS devices are gaining popularity as a convenient method of sharing files among multiple computers. Potential benefits of network-attached storage, compared to file servers, include faster data access, easier administration, and simple configuration. NAS systems are networked appliances which contain one or more hard drives, often arranged into logical, redundant storage containers or RAID. Network-attached storage removes the responsibility of file serving from other servers on a network. They typically provide access to files using network file sharing protocols such as NFS, SMBCIFS, or AFP. Note that hard drives with NAS in their name are functionally similar to other drives but may have different firmware, vibration tolerance, or power dissipation to make them more suitable for use in RAID arrays, which are sometimes used in NAS implementations. For example, some NAS versions of drives support a command extension to allow extended error recovery to be disabled. In a non-RAID application, it may be important for a disk drive to go to great lengths to successfully read a problematic storage block, even if it takes several seconds. In an appropriately configured RAID array, a single bad block on a single drive can be recovered completely via the redundancy encoded across the RAID set. If a drive spends several seconds executing extensive retries, it might cause the RAID controller to flag the drive as down, whereas if it simply replied promptly that the block of data had a checksum error, the RAID controller would use the redundant data on the other drives to correct the error and continue without any problem. Such a NAS SATA hard disk drive can be used as an internal PC hard drive, without any problems or adjustments needed, as it simply supports additional options and may possibly be built to a higher quality standard, particularly if accompanied by a higher MTBF figures and higher price, than a regular consumer drive.
Description.
A NAS unit is a computer connected to a network that provides only file-based data storage services to other devices on the network. Although it may technically be possible to run other software on a NAS unit, it is not designed to be a general-purpose server. For example, NAS units usually do not have a keyboard or display, and are controlled and configured over the network, often using a browser. A full-featured operating system is not needed on a NAS device, so often a stripped-down operating system is used. For example, FreeNAS, an open-source NAS solution designed for commodity PC hardware, is implemented as a stripped-down version of FreeBSD. NAS systems contain one or more hard disks, often arranged into logical, redundant storage containers or RAID. NAS uses file-based protocols such as NFS, popular on Unix systems, SMBCIFS, Server Message Block Common Internet File System, used with MIS Windows systems, AFP, used with Apple Macintosh computers, or NCP, used with OES and Novell NetWare. NAS units rarely limit clients to a single protocol.
NAS versus DAS.
The key difference between direct attached storage, DAS, and NAS is that DAS is simply an extension to an existing server and is not necessarily networked. NAS is designed as an easy and self-contained solution for sharing files over the network. Both DAS and NAS can potentially increase availability of data by using RAID or clustering. When both are served over the network, NAS could have better performance than DAS, because the NAS device can be tuned precisely for file serving, which is less likely to happen on a server responsible for other processing. Both NAS and DAS can have various amount of cache memory, which greatly affects performance. When comparing use of NAS with use of local, Non-networked, DAS. The performance of NAS depends mainly on the speed of and congestion in the network. NAS is generally not as customizable in terms of hardware, CPU, memory, storage components, or software, extensions, plugins, additional protocols, as a general-purpose service supplied with DAS.
NAS versus SAN.
NAS provides both storage and a file system. This is often contrasted with SAN, Storage Area Network, which provides only block-based storage and leaves file system concerns on the client side. SAN protocols include Fibre Channel, ISTC, ATA over Ethernet, AOE, and HyperSTC. One way to loosely conceptualize the difference between a NAS and a SAN is that NAS appears to the client OS, operating system, as a file server. The client can map network drives to shares on that server, whereas a disk available through a SAN still appears to the client OS as a disk, visible in disk and volume management utilities, along with client's local disks, and available to be formatted with a file system and mounted. Despite their differences, SAN and NAS are not mutually exclusive, and may be combined as a SAN-NAS hybrid, offering both file-level protocols, NAS, and block-level protocols, SAN, from the same system. An example of this is OpenFiler, a free software product running on Linux-based systems. A shared disk file system can also be run on top of the SAN to provide file system services.
History.
In the early 1980s, the Newcastle connection by Brian Randall and his colleagues at Newcastle University demonstrated and developed remote file access across a set of Unix machines. Novell's NetWare Server operating system and NCP protocol was released in 1983. Following the Newcastle connection, Sun Microsystems' 1984 release of NFS allowed network servers to share their storage space with networked clients. 3Com and Microsoft would develop the LAN Manager software and protocol to further this new market. 3Com's 3Server and 3Plus Share software was the first purpose-built server, including proprietary hardware, software, and multiple disks, for open systems servers. Inspired by the success of file servers from Novell, IBM, and Sun, several firms developed dedicated file servers. While 3Com was among the first firms to build a dedicated NAS for desktop operating systems, Auspex Systems was one of the first to develop a dedicated NFS server for use in the Unix market. A group of Auspex engineers split away in the early 1990s to create the integrated NetApp filer, which supported both the Windows CIFS and the Unix NFS protocols, and had superior scalability and ease of deployment. This started the market for proprietary NAS devices now led by NetApp and Imxelera. Starting in the early 2000s, a series of startups emerged offering alternative solutions to single-filer solutions in the form of clustered NAS, Spinnaker Networks, acquired by NetApp in February 2004, Exanet, acquired by Dell in February 2010, Cluster, acquired by Red Hat in 2011, Onster, acquired by LSI in 2009, IBRIX, acquired by HP, Isilon, Comanta, acquired by Inc., Polyserv, acquired by HP in 2007, and Panasas, to name a few. In 2009, NAS vendors, notably CTERA Networks and Netgear, began to introduce online backup solutions integrated in their NAS appliances, for online disaster recovery.
Implementation.
The way manufacturers make NAS devices can be classified into three types. Computer-based NAS, using a computer, server level or a personal computer, installs FTP SMBAFP. Software server. The power consumption of this NAS type is the largest, but its functions are the most powerful. Some large NAS manufacturers like QNAP, Synology and Asusta make these types of devices. Max FTP throughput speed varies by computer CPU and amount of RAM. Embedded system-based NAS, using an ARM, MIPS. Embedded system and RTOS to run a NAS server. The power consumption of this NAS type is fair, and functions in the NAS can fit most end-user requirements. Marvell, Oxford, and StoreLink make chipsets for this type of NAS. Max FTP throughput varies from 20 MB per second to 120 MB per second. ASIC-based NAS, provisioning NAS through the use of a single ASIC chip, using hardware to implement TCP/IP and file system. There is no OS in the chip, as all the performance-related operations are done by hardware acceleration circuits. The power consumption of this type of NAS is low, as functions are limited to only support SMB and FTP. Lee Walker is the only chipset manufacturer for this type of NAS. Max FTP throughput is 40 MB per second.
Uses.
NAS is useful for more than just general centralized storage provided to client computers in environments with large amounts of data. NAS can enable simpler and lower-cost systems such as load balancing and fault-tolerant email and web server systems by providing storage services. The potential emerging market for NAS is the consumer market, where there is a large amount of multimedia data. Such consumer market appliances are now commonly available. Unlike their rack-mounted counterparts, they are generally packaged in smaller form factors. The price of NAS appliances has plummeted in recent years, offering flexible network-based storage to the home consumer market for little more than the cost of a regular USB or FireWire external hard disk. Many of these home consumer devices are built around ARM, PowerPC or MIPS processors running an embedded Linux operating system.
Examples. Open source server implementations.
Open-source NAS-oriented distributions of Linux and FreeBSD are available, including FreeNAS, NAS for Free, CryptoNAS, NiceLite, Cluster, OpenFiller, OpenMedia Vault, EasyNAS and the Debian-based turnkey file server. These are designed to be easy to set up on commodity PC hardware, and are typically configured using a web browser. They can run from a virtual machine, live CD, bootable USB flash drive, live USB, or from one of the mounted hard drives. They run Samba, an SMB daemon, NFS daemon, and FTP daemons, which are freely available for those operating systems. NIC Syntaster, built on the Nixenta Core platform, is similar in that it is built on open-source foundations. However, NIC Syntaster requires more memory than consumer-oriented open-source NAS solutions and also contains most of the features of enterprise-class NAS solutions, such as snapshots, management utilities, tiering services, mirroring, and end-to-end checksumming due, in part, to the use of ZFS.
List of network protocols used to serve NAS.
Andrew File System, AFS, Apple Filing Protocol, AFP, Server Message Block, CIFS, former Samba, File Transfer Protocol, FTP, Hypertext Transfer Protocol, HTTP, Network File System, NFS, a Unix protocol, RSYNC, SSH File Transfer Protocol, SFTP, Universal Plug and Play, UPnP.
Clustered NAS.
A clustered NAS is a NAS that is using a distributed file system running simultaneously on multiple servers. The key difference between a clustered and traditional NAS is the ability to distribute, for example stripe, data and metadata across the cluster nodes or storage devices. Clustered NAS, like a traditional one, still provides unified access to the files from any of the cluster nodes, unrelated to the actual location of the data.